Hello. So we've recently been talking about functions, um, what makes a function, what makes something not a function, how to tell what a function is from a graph, from a table, from an equation. Today we are going to learn what, excuse me, what x and y intercepts are and how to tell what those are given a graph. Okay, so by the end of this lesson, you'll be able to tell me exactly what an x-intercept is, what a y-intercept is, and how to figure out what those things are given a graph or an equation. All right, so let's go ahead and get started. We're going to start with notes, and then you all will have a classwork afterwards, just like usual. So in this set of notes, this is our lesson 5, functions and relations. We've been on this for the last few lessons. Our essential question basically is going to be exactly what I said you're going to be able to do by the end of this lesson. So by the end of this lesson, or this question, the essential question is going to be how, why am I not typing? How can I determine, x and y intercepts, CEPTS, when given a graph or an equation? HEN, given a or an EQUATION. There we go. When given a graph or an equation. All right. Got a little bit of a typo here. Let's fix that. All right. So this is your essential question. And by the end of this lesson, you will be able to answer this essential question. So let's actually get started on what these things are saying and get some stuff on the page. So the solution of linear functions are the x-intercepts. All right. And if you don't know what that is, that's okay. I'm going to explain that to you. Okay. X-intercepts happen where the graph crosses the x-axis. All right. Where the graph crosses the x-axis. So solutions to linear equations, which are called the x-intercepts of linear equations, those are also called roots, which is one here, or zeros. Okay. So we've got x-intercepts, roots, and zeros that all mean the same thing. Those are solutions to linear equations, and they also cross, that's where our graph of our linear equation crosses our x-axis, okay? So an intercept is always written as our number, whatever our number is. I'm just going to do that. And then a 0. Since it's on the x-axis, it's going to be a 0 for that y spot. That's why we have our number. We're given our number. We're going to write it as a number and a 0. All right. A solution is always written as x equals. Let me put that actually in my equation editor so it looks the same. X equals whatever that number is, okay? So x equals a number. Our intercept is always written as a number and 0 in an ordered pair, that number and the y being 0. And then a root and 0, roots and zeros are written as a list. They will be written as a list, okay? Kind of like, excuse me, like we wrote the domain and range, they will be written as a list, okay? So now let's look at an example of this. This says to ask us to identify the x-intercept, solution, root, and 0 using the graph to the left. So once again, our solution, our root, and our 0, and our x-intercept, those are all for the most part the same thing, but the way we write them is the only thing that's different. When we're looking at our x-intercept, we're going to write that as an ordered pair, okay? We're going to write that as an ordered pair. So let's actually go ahead and find this. Look at this graph. And when we're looking for x-intercepts, that's going to be where our graph crosses, where the graph crosses the x-axis, all right? And in case you don't remember, my x-axis is here and my y-axis is here. Actually, you know where I'm not even gonna cover the y-axis much right now. My x-axis is here. It's the one that goes side to side, all right? So my x-intercept is gonna be the point at which this graph crosses this x-axis. So let's look for that. I don't have anything there. Oh, here we go. At x equals 2 is where I have a solution, and that intercept will be 0, not 0, it'll be 2 comma 0, all right, because that's how we're going to write our intercepts. We write them as ordered pairs. Our solutions will be written as equations. So the solution, a solution to this would be x equals 2. And then our root is going to be 2, our 0 is going to be 2. Those both mean the same thing, where the x crosses, or where the graph crosses the x-axis, all right? So all of that means the same. So now that we've done x-intercepts, let's look at some y-intercepts. So this here, let me change colors. Yeah, I'll use green. The y-intercept of a linear equation, of a linear function, occurs when the graph crosses the y-axis. All right, very much like the x-intercept. The x-intercept occurs where the x crosses the, where the graph crosses the x-axis. The y-intercept occurs where our graph crosses our y-axis. So a y-intercept is always written as 0 and the number for that, whatever that number might be. And you can identify the y-intercept when given an equation by writing our equation in slope. Goodness, I can't type. Slope intercept form. Okay. Slope intercept form. And that's just going to be that y equals mx plus b. In case you don't remember, I want to put that one in red because that's an important one. Y equals mx plus b. That formula there. This b here is going to be our y-intercept, all right? And that's why it's called slope intercept, because we're given our slope, which is m, and our intercept, which is b. Okay, so now let's look at an example. Example says, identify the y-intercept and slope using the graph to the left. So we know how to count graph or count for slope. Let's start off looking at the y-intercept. So our y-intercept is going to be, let's use this color here. In case you don't remember, this is going to be my y-axis going up and down. I'll mark that for you. So we're going to look where the graph crosses this y-axis, and that's going to be right here, right here. All right, so my y-intercept for this is going to be, remember our format is 0 and then our number. So we're going to have 0. Actually, I want to use that color. Let's use that green. Use that. We're going to have 0. And then our number in this case is -6. So that's what we get here. And then our slope, we have to actually count our slope. So we already have 1 point. We have a starting point. Let's pick another point. When we are looking at a graph, the way we measure, or the way we find our slope, is we pick 2 points, a starting point and a stopping point going from left to right. And then we count. I'll use red again, I suppose. So, and the way we want to pick these points is that we want to make sure they line up with the crosshairs that are on the graph. So here's one that lines up. And then we count our rise over our run. All right. So I go up once, 1, 2, 3. So I have a 3 for my rise. And then I go over once and I have a 1 for my run. And so since this is rise over run, ooh, that's a tongue twister. That's going to be 3 over 1. And now remember, when we write our slope, we want to write it in its simplified form. So 3 over 1, we're not going to leave it like that. That's going to become 3, okay? So our slope is 3. So when we want to determine the y-intercepts from an equation, we're first going to identify which intercept we're looking for. So we're going to read the question to figure that out. Then we're going to cover up the term with the variable that we are not looking for so we don't get confused. Then we're going to solve the one-step equation if we need to. And then we're going to write our final answer as an ordered pair. Okay? So example, this says find the x and y intercepts of the equation x minus 2y equals 12. So first, identify which intercept we're looking for. In this first one, we are looking for the x-intercept, all right? Since we're looking for the x-intercept, I'm going to put a box around it. My next step says to cover up the term with the variable that we are not looking for. So let me go ahead and retype out, or if you're working on paper, you can rewrite out your original equation, x minus 2y equals 12. And then it says, cover up the term with the variable that we are not looking for. So we're looking for our x. So we're going to cover up our y. And I'm just going to scribble through it. That didn't work all that great, did it? Let's scribble through it in red. All right, there we go. That's a bit better. So since now that we've done that, step 3 says to solve the one-step equation if needed. Do we have to solve this? Is this a one-step equation? Nope, it's just a straight up x equals 12. And then it says to write your final answer as an ordered pair. Now remember, for the x ordered pair, our answer looks like number, comma, 0. So that's what we're going to put here. Our number here is 12, comma, 0. Now, this isn't just this isn't an order pair where I've written this. This is just two numbers next to each other. I have to put them in parentheses in order for them to be an ordered pair, right? So here we go. We've got this first one done. Let's look at the second one. The second one says, find the y-intercept, okay? Find the y-intercept. So since I'm looking for that y-intercept, first off, let me type out this equation again. X minus 2y equals 12. Let me slide this over a bit. I'm looking for my y-intercept. So I'm going to cover up my x. That's a bad cover up. There we go. My x. And now what I'm left with is this negative 2y equals 12. So I've done step 1 and I've done step 2. Now step 3 says, excuse me, solve the one-step equation if needed. So we're going to solve this if needed. To solve this, you guys all know how to do this by now. Divide both sides by negative 2, and we end up with a y equals, what is that? My math is terrible. Negative 6. I'm just kidding. My math is not terrible. I'm a math teacher. But I do make mistakes sometimes. All right. We have y equals negative 6. And so our last step is to write our final answer as an ordered pair. When we go to write this as an ordered pair, when we're writing our ordered pairs for y-intercepts, we write 0 first, and then what our actual value is. This one is negative 6, okay? So 0, negative 6. That's going to be our answer for this one. All right, our next couple of examples, I'm going to do number 1, and I'm going to save number 2 for you all. It says, find the x-intercepts, roots, zeros, solutions, and y-intercepts of each equation. Use the ordered pairs to draw the graph. All right, so first we're going to find the y-intercepts. When I look at this one, I'm like, oh, snap, what's going on here? I see that I can, excuse me, that I can use the method above in our notes to determine the x and y intercept. So our x-intercept, first we're going to identify which one we're looking for. We're looking for the x. So we're going to cover up this y. cover that up, and that's going to be that 4x equals 12. I'm not going to leave that covered up, but just so you can kind of get the picture, we end up with on this side, negative 4x equals 12. Oh, what happened? Did I type? I guess I didn't. Negative 4x equals 12. And we solve this one-step equation, all right? I'm sure you all are able to see that this one is going to be x equals, we divide both sides by that negative 4. So that's going to be an x equals negative 3. So my x-intercept, that's going to be, and I want to put some color to this one. This x-intercept is going to be negative 3, 0. Now my root is also going to be negative 3. If you think back ahead to the notes we did before, my roots and zeros are all the same. My roots and zeros are the same. It's just going to be that x value. And now my solution, however, my solution is the same value, but we write that differently. That one is written as x equals negative 3, okay? And now it's asking for my y-intercept. My y-intercept is going to be, to find my y-intercept, I'm going to scribble out my x right here. And what I end up with is 3y equals 12. So let's undo that. And then I'm going to go ahead and type out that new equation. 3y equals 12. And to solve this one for y, I just divide both sides by 3. I'm sure you guys know that. 12 divided by 3 is 4. And so my y-intercept, the way we write that one, is going to be 0 in my x spot and my resulting y. So it's going to be 0, 4. And don't forget to put your parentheses around these intercepts because these are ordered pairs. All right, so there we go. We found our roots, our zeros, our solutions, and our y-intercepts and x-intercepts of each equation. Now it says use the ordered pairs to draw the graph, okay? So here's one ordered pair, negative 3, 0. Let me go ahead and color that, find that one. And so this is my x-axis. This is my y-axis. I'm going to put it on the bottom. All right, so negative 3, 0 is my x-axis. So I'm going to go to negative 3, 0. 1, 2, 3. That's right here. And then I go to 4, 0 for my y-axis. I mean, not 4, 0. 0, 4. Okay, you want to be careful about when you go to plot these because it's really easy to make a mistake with that. That's that I could go to 4, 0 and that would just completely mess me up because that would just be here. And that wouldn't be the graph of this equation. Instead, I'm going to go to 0, 4. 0, 1, 2, 3, 4. There we go. And then we're going to draw a line. Since we're using Cameo, I'm going to use my little line drawer tool and just go straight from here right up to that one. There we go. And there we have it. We have our line. And since this is a line, don't forget to draw your arrows, okay? Because lines don't stop. All right, you all go ahead, do number 2. If you need any help, let me know. When you're done, go ahead and just summarize the entire process. And if you've gotten stuck at some point or can't figure out what's going on, go ahead and write that as your muddiest point, okay? That way, when I read them, I know what to go over. So yeah, go ahead, take some time, do number 2, ask questions if you have them, and work on the classwork when you're done, all right?